Hello students. Today's topic of discussion is space physics. This is the third video in this series of space physics, and in this video we're gonna discuss about the Earth orbital speeds, Kepler's law, and few more interesting concepts, how Earth rotates and what are its impact. First thing is Coriolis effects, Earth rotation and its effect on weather. So, key to this Coriolis effect lies in the Earth rotation. Specifically, Earth rotates faster at the equator than it does at the poles. Earth is wider at the equator, so it makes a rotation in one rotation in 24-hour period. And equatorial region race nearly at 1600 kilometer per hour. That's the speed near the equator. And near the poles, Earth rotates at the sluggish speed of this value. So it's a quite difference. So at the pole, it will be moving very slowly, and the equator very fast. Okay. So what will be the effect, and what this Coriolis thing is? How are we gonna define it? So the Coriolis force, it is an invisible force that appears to deflect the wind in the Coriolis force, and it applies to the movement on the rotation of object, and it is determined by the mass of object and the object's rate of rotation. There is the two things. One, it depends on the mass, and another, the rate of rotation. Okay. Coriolis force is perpendicular to the object's axis. So it will be perpendicular to the axis of Earth, and the Earth spins on an axis from west to east, that all of us know, and the Coriolis force therefore act in the north-south direction when it will be perpendicular to Earth axis. Coriolis force is zero at equator, that you have to keep in mind. What are the effects of this Coriolis forces? So first is development of weather pattern such as cyclones and the trade winds are the example of impact of Coriolis effect. One more interesting factor there, like military snipers sometimes have to consider this Coriolis effect to aim perfectly. Now the one more thing, what would happen if the Earth were actually flat instead of being spherical? Obviously there would not be gravity, that gravity we are experiencing right now. So what sort of gravity it would be, or what will be its effect? So as we know about the gravity suggest it would pull toward the center of disk if it has been like a flat. So that means it would only pull straight down at a point on the center of the disk. As you got increasingly far from the center, gravity would tug more and more horizontally. And what would happen then? This would have some strange impact, like wherever there is a water body on the flat surface of the Earth, it will get attracted towards where the center of Earth. So means center of that disk, and the trees or the plants that grow will grow diagonally, as we know, since they develop in the opposite direction to the gravity pull. So these might be the effect. You can think about this thing, and if you find any more interesting point regarding what if the Earth were actually flat, so you can put your thoughts into comment section. Then Earth's orbit. So some information regarding the orbit of Earth. So Earth orbits the Sun once approximately in 365 days, and this is 1 year. And the combination of the orbiting of Earth around the Sun and the Earth tilt creates a season that we observe. Okay, so pictorially it has been shown what will be the position of Earth, then which sort of season we will be experiencing, like winter, spring, summer and autumn. So I have also mentioned the dates also, so you can analyze how it varies. Okay, now the sun rises in the east and sets in the west, and its approximate area changes throughout the year. So what happens, the sun is highest above the horizon at the noon 12 p.m. And in the northern hemisphere, the daylight hours are longest up until the roughly in the 21st June. And this day is known as summer solstice and is where the sun is at the highest point in the sky all the years. Then on the 21st of December, what happens? The daylight hours then decreases to its lowest around this date, 21st December, and this is known as winter solstice and is where the sun is at its lowest point in the sky all the year. This is the sun, and this is the orbit of moving the planet Earth. So it is an elliptical orbit. Okay, so circular orbit will look like this. This moves in the elliptical orbit. So a few times it will be nearer to the sun, few times it will be farther from the sun. So those things we'll discuss in more detail in the Kepler's law. Then comes to this Kepler's law. It is a very important concept, and there is a high possibility of getting questions from these topics. So he has given three laws. First is all the planets moves around the sun in elliptical orbit with the sun at its one of the foci. In circular orbit, what happens? There is a center and there is a circular path around it, and the radius will be same all over the circle. But in elliptical orbits, the radius will be, the value of radius will be different. So there will be two axes, one minor axis and one major axis. So this axis is a major axis and this one is a minor axis. Okay, and this is the focus 1 and the focus 2. So the position of suns keeps on changing. So one time when the earth is nearest to the sun, then we call it perihelion, and when it is the farthest from the sun, then we call it aphelion. So the first law is what? All the planets moves around the sun in elliptical orbit. Move on to the second law. The planets swaps equal areas in equal interval of time. So pictorially you can see it. This is area 1. Okay, so this one is the sun and the earth is moving around it. So in this distance 1, so this area, if we'll calculate whatever the value will be, it will be the same as the area 2. Might be looking different, but if we'll calculate, it will come same. So time taken to travel a distance 1 will be equal to time taken to travel the distance 2. So it means area of 1 will be equal to area of 2. So this is the second law, that a planet swaps equal area in equal interval of time. Now move on to the third law. The square of the orbital's period, that is t square, time period of a planet, is proportional to the cube of orbit's semi-major axis. So there are the two axes. This one is a major axis, so half of this semi-major axis. So what it is saying, the square of time period t square is directly proportional to cube of the semi-major axis. Okay, t square directly proportional to a cube or r cube. Okay, so these were the three laws of Kepler's, but currently they are saying now it is, this time it is not moving around the sun exactly. So what is this? This is the position of sun, and so the center of mass of the sun along with the planet is different. It can be inside the sun also and outside the sun also. So all these dots, all these black dots are there, this representing the center of mass of the system. Okay, so if you look, this is the sun and this is nucleus of sun. So only few times, these are the years when this center of sun and center of mass of the system was nearly same. Okay, these were the years, and all these pointers were in the sun. Okay, but now in the few times, like these years, all these years, 1945, 55, 1981, 1959, 1994, so all these pointers are outside the sun. Center of mass is outside the system, outside the sun. Okay, so if now earth will be just rotating around this, so we can say that it is not revolving around the sun, but it is revolving around the center of mass of the system. So what that point is, So what is the very center and how does it explain the claim that the earth doesn't revolve around the sun? So it is the center of mass of two or more bodies that orbits one another and is the point about which the bodies orbit. So very center is a dynamical point, not a physical object. Okay. So currently the center of mass of system is outside the sun. So orbital speed is equal to length of the orbit upon orbital period. So length of the orbit is the circumference. So circumference is 2 pi r divided by time period. Okay. So orbital speed will be given by 2 pi r upon the time period. Now few questions related with this. So these are the solution part of the respective questions. Okay. If you have any doubt regarding these questions and the solution, we can put the things into the comment section. Now, a few more bonus questions. For these questions, you will not get the solution. So solution of these you have to put into the comment section. It is a test question. Okay. So these two questions. Thanks a lot for watching the video.